Very excited to talk to Deep Nishar. Now he's, leading the 4.6 billion, I guess, you have access to at General Catalyst, leading growth, and not quite the 100 billion that maybe you had access to during your time at SoftBank. Obviously, also an experienced exec at LinkedIn at one time. So very excited to talk about sort of the market, where I'm sure we'll touch on the letter and your points of view. I just wanted to start off in particular, you spent some time in healthcare, which is, I think, something we haven't talked about as much here in terms of AI. I'm curious, what you think people should be tracking in terms of, generative AI hitting the healthcare space and what you're looking at and what you're excited about there.
It's a great way to start because we haven't talked about it. For the people in the room who are not kids, you may remember that there used to be something called genetic algorithms in AI long before neural nets and DNNs and GNNs became popular. So there is something to be learned even in the way AI is progressing that came from what we know about genomics. There are probably three places where AI can be very helpful, and we're already seeing a bunch of companies. We've funded a few of them. The first is protein is like the lifeblood of any cell, and it's the workhorse of what happens. We know very little about how proteins work. And of course, with AlphaFold, everyone's now thinking about proteins.
I know, I'm always asking, I was doing folding at home back when I was in high school on my laptop, the network. Feels like we've been working on the protein folding for ages.
For a really long time. But the thing is, proteins are really, really tiny, and they're moving all the time. So the way you try to figure out the structure of a protein typically is you take cells, you freeze them, you do cryo-EM, then you put X-ray diffraction technologies, you look at shadows, and then you try to figure out what that protein structure is, pretty arcane and archaic. 2 Nobel Prizes have been won on that particular technique. Now with AlphaFold, you can actually figure out how proteins are folding in a dynamic way, and the proteins are the locks, right? And the drug molecule that you create is the key. So the first thing you can do is, in terms of biotech and AI ML, is we can actually put in and predict how the proteins are going to fold. So once you understand the target, Viswa's here, he can tell you all about it later. You can actually figure out the right keys, the molecules that can go and bind against it. Enveda.
Okay.
So that's one thing. The second thing you can do is you can actually figure out the chemistry that's going to be the best in terms of hitting those targets. A lot of times when we model drugs, there are side effects. And that's why you read all the things. You go to the pharmacy and they tell you you can get nausea, you can get diarrhea, etc. The reason that happens is because you're not hitting the target in the appropriate way, because the chemical structure is little bit off. You can do that better. And the third, the most important one, is when you know both the biology of the target and the chemistry, you still have to find the best possible thing that will hit it, and that's the throughput screening. And now with AI and ML, you can actually go through hundreds of thousands of drug candidates and cull it down to something that could be the most promising and hit that target fast. And we saw an example of that. One of my portfolio companies, Veer Bio,
they found what's it called?
Veer Bio, VIR. Sorry, Indians V and W sound.
No, I just want to make sure everyone can Google it afterwards. I always want to know the company.
Yeah, we split it up. They came up with an antibody for COVID that worked all the way up to the Delta variant. And that was 85% effective. So it was more effective than when Paxlovid is today. And the way they came up with that antibody was running very high throughput AI ML screens against antibodies that were available for the SARS-CoV virus. And that worked on COVID.
I didn't ask you this in advance. I hope it's not too personal. But are there ways where your personal healthcare is better because of some of these companies? Or are you able, being at the cutting edge of looking at these companies, able to get some advanced personal healthcare? Or how much is it available yet? Or is it only if you have some edge case disease where it's really useful at the moment?
No, a lot of that, thankfully, I've personally never had to use any of these techniques. But I've had friends, a very recent case, a friend's mom was in India and with an infection that they couldn't figure out, and she was in very bad shape. There's a company called Carius here that takes a blood sample and runs it through 2,000 pathogens, and within 14 hours can tell you what your infection might be, which is very different than what happens right now. So what happens right now, if you have an infection, your doctor looks at you and they're like, okay, chances are these 4 or 5 things. They'll take a blood sample, they'll send you to the lab, and they'll check for those 4 or 5 markers. if one of them comes out great, they know what to give you. If it doesn't come out, you're shit out of luck, because then they have to send it back. And then again, and if you have something that's a little bit rare or different, you could be in dire straits, especially if you are like immunocompromised, an older person, a younger person, or have some other immunological diseases. That can be a problem. So we were able to help her and get that blood sample from India and so on.
That's amazing.
Yeah.
In terms of like large language models, I feel like I saw a viral one on Twitter where somebody, like, their dog was sick, they've been to the vet, they put it into ChatGPT, and then ChatGPT sort of gave them like the most common thing, but then they went to another vet and said, is it this most common thing? And it was, and a previous vet had missed it. Like, I mean, it feels like with animals where we have some comfort with that. Are you seeing the large language models applied to human medicine yet? And yeah, how optimistic are you that they'll be helpful?
So the funny thing, Eric, so I had the opportunity to start Google's mobile efforts like in 2004, 2005. So our team built like the first Google search on mobile devices. And I'll tell you, like, true story, one of the first emails we got back saying thank you was the following. Father had a newborn. The newborn was born with had some issues. The doctor said, we have to have surgery right away. The parent was like, that seems like a very drastic surgery on a newborn. We should check it out. They did a Google search. They found some condition, and they asked the doctors, like, could it be this? So Google doctor, this was 2005. Okay. So as long as information is available, there are enough techniques to go figure it out. You don't need large language models for that. The place where large language models and all these search techniques help us is medicine is a very empirical science, right? Like doctors, they go through like 5 years of cramming shit in their head, and then they have to recall it. And they have to recall it in the context of what they know. So, I come back with a fever. Let's say I've just been to Africa or India or some places where malaria is very common. If I don't tell my doctor that I was just in a place where tropical diseases are common, they're not going to look for malaria in Palo Alto, because they're like, there are no malarial mosquitoes here. So like, they wouldn't even check for that because their empiric evidence doesn't tell them look for that. I need to know enough to like tell them that, hey,
in some
I was
ways you're saying the shortage of time with doctors, whereas the unlimited time with the LLM, it's like, okay, you could enter everything.
Yeah.
The LLM could flag, like, here are the key things that you might not have communicated to
It's
your
a
doctor.
great decision support tool for them. And by the way, that's a much better co-pilot, I think, than like, coding co-pilot. Like, let engineers do their jobs, but like doctors can save our lives. So let's give them
You're more excited
data.
about the medical co-pilot. Yeah, that's exciting. I mean, there's sort of a subtext with the letter here, right? Like, one of the strong arguments against this letter that we've been talking about all day, warning, calling for a halt in research, is that like, what could be lost, right? I mean, there could be, in 6 months, some great medical technique. I'm curious, what your view on the letter is, especially as someone thinking about sort of the medical work that's happening.
Yeah, I mean, I know one argument that was made here earlier today was like, oh, it's a huge cost to humanity if we stop everything for 6 months. Bullshit, right? I mean, humanity's gone on for hundreds of thousands of years. We'll go on for a lot longer. We'll die by suicide, not by homicide, because LLMs didn't show up one day. Having said that, I think
that was a strong argument for stop, because we'll be able to do the 6 months down the road. You're like, we can stop.
Progress is never stopped. And I don't think, like, the stop part is a red herring. Like, we should all agree and accept that people are saying it because what we have built to date, right, is the first time in history that a massive technological shift is both opaque and stochastic. We don't know how it was built and what it's doing, and it's not deterministic. So, like, if you go to ChatGPT and type the exact same prompt like 5 times in a row, you do not get the same exact response.
I just want to underline, we're having like the most insider AI conference in the world, and a recurring take is we don't actually know like why it produces it. Like that's like a truly amazing.
That's a feature, not a bug. That's the feature of how neural networks work, right? Because they traverse themselves, and they are assigning the weights by themselves, and no one is out there like looking at the weights and saying, okay, how did these things work out? Like, these are giant matrices within matrices within matrices. Whoever made the matrix, smart man, right, or woman, whoever made it. The point is, that's what this letter is all pointing us to. So go back to biotech, how we started the conversation. There was a very fundamental conference in Asilomar, which is not too far away from here, where the key genetic researchers of the day got together, and they said, look, we know where this technology can go. Eventually, like, we can change the way fetuses are designed.
Exactly.
If you will. And they sat down and they came up with a set of rules and they said, look, there are some things that we just shouldn't touch, even if they are available to us, not in the name of science, not in the name of research, because they are fundamentally bad for humanity.
All right, I was literally arguing with someone about this last night. Yeah, so the argument is basically, if we didn't do human cloning, then we can stop technological
And yet,
advancement.
somebody did go and do human cloning, right?
Elsewhere,
right?
yes.
Well,
But we
elsewhere is China.
minimize-
I mean, that's
right.
got like the second largest population in
Right.
the world now, as of like March 1st, after India. But
I just don't think there's not the same strong moral intuitions with like AI. I mean, people are worried, but like I feel like human cloning, you poll the random person, and they're more worried about it. Like,
because
is
that's
there
in
enough?
our face, right? That's in
Right.
our face. Like we can see it, and we don't want like like where does it stop? You can say, look, if a baby was going to be born with like a loss of hearing, like would the parent want them to be able to hear? You'd say yes, but then there's a whole set of people who are like, why do you assume that's perfection, etc. In our case, like in the case of AI, it's like, it's software. What happens if it generates like some video here or there, and and then the next thing you know, like people are creating like really bad stuff on it, and there is no way to stop it.
Is there any like? I mean, it's a practical industry. Anything practical you'd say we can do, or?
A first step could be, just like if you take a page out of the Biotech Asilomar conference, is like, you have, and I'll miss a few people, but like, let me, a Jeff Dean, a Jan LeCun, an Andre Karpathy, like,
Collude, meet up.
Greg Brockman, not collude, like get together and talk about what's happening. I think the reason they talked about AI labs in that letter most likely is because that's where the bulk of the research is happening, right? It's not like there are hundreds of thousands of places where interesting applications are being built, but the core fundamental research, like get a Percy, get a Chris Ray, like get folks together to at least just talk about it. And being the one thing I learned being very early at Google, LinkedIn, and now at GC, we place a lot of importance on is intentionality of what you build. Okay, just letting things sort of go in their own way, and then you have bad consequences. You're like, it wasn't in my hands. Like, I gave the tools to the world, and the world decided to do a bad thing. But no, things were in your hand when you could have done something about it.
If you
do
build
something
it,
about
I mean, it sort of came up in the stability conversations. Like, you fired the starting gun in a certain way. Google, I mean, you work there, you know Google well. Like, getting our more, like, strategic heads, where are they in this? I mean, some people are, there's a lot of people making fun of them relative to Microsoft. Like, what's your view on how Google is positioned here?
Well, if you just look at the data between Google and OpenAI, 50% of all the important algorithms and models that have come out in the last 5 years have come out from those two places, with Google contributing more than OpenAI.
And Google, obviously, the Transformer paper itself came out of there.
And BERT and a lot of other things along with it before and after.
So you're bullish long-term on Google's position here?
I still hold the stock I got in 2003.
That's savvy. In terms of you're someone who's had access to of billions, money that's unimaginable to me to deploy. I mean, can you invest too much in a good thing? Like, I mean, SoftBank was very bullish, especially with Vision Fund 2, on AI. That doesn't necessarily make it great returns, and you can just sort of pour more money than sort of technologists can absorb. Or having sort of experienced the Vision Fund, like what lessons do you learn from that pace of capital deployment in the face of promising technology?
So, I learned a lesson like 20 plus years ago when I started a company in enterprise infrastructure software, and that was all about like managing APIs before APIs even existed. So that was the right idea, but probably 10 years too soon. I think SoftBank had a similar idea, which is AI is going to change the world. And we started investing in AI companies in 2017, so the previous generation to LLMs. And unfortunately, the pace of investing was such that before you could hit this generation of AI companies, the fund sort of depleted itself. So the same lesson again, which is like you can have a great idea, but you also have to have it at the right time. And that was one of the challenges. Now, having said that, some of those companies are now actually in the new world doing really well, like Samanova Systems, which has built like very specialized AI chips that has both hardware and software stack and can run all of these models like very, very efficiently. In Citro, that's in the drug discovery space. YN AI, that's one of the things that no one has talked about here is like we are all building companies in the valley to sell to other companies in the valley. There's a whole world outside of like 94022 zip code where people have a ton of money and they don't know how to deploy any of this stuff, and they are willing to give you a lot of money to buy your software.
Right. How do you look at the growth rounds competing against a Google, Microsoft, Amazon, who like the money's going to flow back to them? How do you compete in those deals? Like, has that pushed you to sort of hold back at all? The idea that you're competing against companies that can play a different game.
The investment business is not a wait and watch business, because that's like timing the market, and I honestly don't know anyone who times the market consistently well all the time. Our job is to make the best possible investment decisions given all the information you have at that point in time, and that might mean like you wait 6 months until a company matures a bit more. You go early, you go in at the right price, etc. So value and valuations have diversions and conversions over periods of time. And in the public markets, I think value and valuations have converged quite a bit. In the private markets, they are a little bit diverged right now.
Right, especially in this space, right? I mean, this is sort of the challenge. I feel bad for like software companies that are on the borderline of AI because they get thought too much of software. Their multiples are destroyed. Yeah, is it just the promise of AI, or like, do you think AI valuations come down to earth this year, or you think they're just going to keep going up?
I think we should realize one thing, which is like, AI by itself doesn't do anything, right? AI is the fuel that powers an engine that actually, goes in a car that takes you from place A to place B. So the AI that we are talking about has to go in some software that's solving a real problem that is a high enough value that people are willing to give you money for that. So that's how we should be thinking about these companies. Like, no, it's not technology for technology's sake. Like,
right.
That's interesting. But unless you have the iPhone and the App Store alongside it, like by itself, iOS doesn't do much for you.
If somebody has a burning question, I'll throw it to you. Otherwise, I'm going to keep going with the last one. Oh, sure.
Hey there. What do you think about the role of AI in like personalized health and behavior change, like society-wide?
I think AI can be a good aid there, just like any other software. But the fact of the matter is, like, when you're talking really about personalized healthcare, most of us know that if we eat right and exercise, unless we have some genetic issues, we should be reasonably healthy. Yet we don't do it because it's a lot easier to, eat that really nice chocolate croissant outside as opposed to like go for the granola or, whatever. So AI can just keep nudging us. Eventually, we have to take the action. This is why, like, taking a little bit slight tangent, the GLP-1 drugs like Ozempics of the world are all the craze right now, even for non-diabetics, although they are meant for type 2 diabetes, because it's an easy way to lose weight, right? Why go to the gym for an hour a day and like eat salads when you can eat pancakes all day and just take a pill at the end of the day?
I'm also thinking about, like, there's a difference in how people's bodies respond to different chemicals, right?
Yes. So that's less about AI, honestly, and that's about monitoring your biomarkers. And that is actually very key. So, if people really want to understand what's going on with their body, say for sugar, having a CGM is great directionally, because for some people, like eating a mango may really spike your sugar. For other people, it may be watermelon. And you can eat one or the other, but we don't know that. Generically, the doctor will just tell you don't eat any sweets. Well, that's kind of hard, right? Like, it's like the card which says, like, when you're 40, like, don't eat sweets, like, don't have a spouse, and like, don't have fun, don't drink, and then it's like, is life worth living?
All right, well, we're headed into a 20-minute break. Thanks so much. Fun to talk about sort of the actual health implications of these, not just sort of chatting. And so super fun, and see you in 20 minutes.
All right.
Great.
Cool.